My name is Bala Narasimhan, and I am the product manager for the ParAccel Analytic database. Welcome to this technical deep dive on the Extensible Analytics feature in PADB 3.0. The Extensible Analytics feature in PADB 3.0 introduces two user-defined function interfaces. The first is that of a scalar function, and the second is that of a table function. A scalar function returns a single data value. In contrast, a table function returns a table. Both of these UDF interfaces can be used in SQL statements such as DDL statements, DML statements, and hybrid statements. A hybrid statement is a SQL statement that has a combination of DDL and DML operations in it. Here are some examples of using table functions in SQL with PADB 3.0. In the first example, the table T1 is an input to the table function 1. In the second example, T1 is an input to table function 2, and the output of table function 2 is an input to table function 1. In the third example, the inner query returns the column A1 in T1, and that column A1 is an input to table function 1 in the outer query. The fourth example shows how you can use named parameters with table functions. And the fifth example shows how you can use aliasing with table functions in PADB. Note that it is optional to specify the partition by and order by clause when using table functions with PADB. This is because we believe that the partitioning and ordering of data is an attribute of the algorithm manipulating the data, and that as a user of the analytics, you shouldn't be concerned about how the data is partitioned or ordered. Table functions in PADB are multi-phase. A table function can have one or more phases. For example, if you are looking to implement MapReduce-like functionality using table functions, you could have one phase that does the map operation and another phase that does the reduce operation. Each phase can define its own partitioning logic and its own ordering logic. Let's now talk about the life cycle of implementing a table function in PADB. As I mentioned earlier, a table function in PADB can have one or more phases. Each phase will implement what's called a describe command. The describe command has access to input schema for that phase and also access to the named parameters for that phase. The describe command also defines the output schema for the phase and any data partitioning and ordering logic. The create command instantiates the table function object. The row processing function is a function that manipulates the rows that are input into the phases in a table function. When you are implementing the analytics to operate on the data, this is usually where the meat of the analytics is implemented. The finalize command is invoked when there are no more input rows, and it is the last chance to output rows from the table function. Finally, the destroy command is when you would clean up the resources associated with a table function. In addition, the Extensible Analytics feature also provides a number of interfaces for operations such as memory management, row and column management, logging and tracing, and error handling when you are implementing a table function. This improves the usability of the Extensible Analytics feature in PADB tremendously, and it makes implementing analytic modules via table functions very easy. Let's now look at some code that will show us how you can write a table function in PADB 3.0. We're going to talk about the word count example. The word count analytic function is one that takes a character column as an input, it then tokenizes the sentences in that character column and tells us how many times a particular word occurs within that column. Word count is a two-phase table function and is an example of how you would implement MapReduce like operations within PADB. For example, let's suppose you had a table called animal in your database, as shown here, and that the table animal has 4 rows in it. When you invoke word count on this table animal, it will tokenize each of these 4 sentences and count the number of occurrences of cat, dog, lion, and tiger in those sentences. As you see here, when we invoke the word count table function on animal, it tells us that there are 4 occurrences of dog, 4 occurrences of cat, 4 occurrences of lion, and 4 occurrences of tiger in the table called animal. Here's a bare bones example of how you would implement a table function in PADB 3.0. In this example, we have a class called UDF class, which is going to implement a user-defined function, and it inherits from the parent class called table function. As I specified earlier, this table function will have a describe command, a create command, a finalize command, and a destroy command. Here's an example of the interfaces that the Extensible Analytics feature is providing for users to implement table functions. Throw error is an error handling interface that we are providing with PADB 3.0 that allows you to throw errors when you detect a condition, an error condition as part of the table function. In this case, if you find a command that does not match one of describe, create, finalize, or destroy, you can throw an error saying this command has not been implemented. This example is that of a table function that has a single phase in it. Let's now look at an example of a skeleton for a two-phase table function. Here we define a UDF base class which inherits from the table function class. We then define a UDF first phase class which inherits from UDF base class. This class implements the first phase of the table function. We then have another class called UDF second phase class. It too inherits from the UDF base class, and it represents the second phase within the table function. Note that both phases have their own describe phase and their own process function. The describe phase will have access to the input values to that particular phase and will define the output schema from that phase. And the process function is what will operate on each of the rows that are input to that particular phase of the table function. Word count is an example of a two-phase table function, and we would implement word count using this skeleton for two-phase table functions. I hope you enjoyed this technical deep dive to the Extensible Analytics feature in PADB 3.0. My name is Bala Narasimhan, and if you have any questions, please visit www.ParAccel.com.